Euclid of Alexandria, a name synonymous with geometry, stands as a towering figure in the history of mathematics. Revered as the father of geometry, his contributions to the field are unparalleled. Euclid's work laid the foundation for geometric understanding for over 2 millennia. His systematic approach and rigorous proofs have inspired generations of mathematicians, scientists, and thinkers. Euclid's masterpiece, The Elements, remains a cornerstone of mathematical thought. This seminal work, comprising 13 books, presents a comprehensive system of geometry based on a set of definitions, postulates, and axioms. From these fundamental principles, Euclid deduces a vast array of geometric theorems demonstrating the power of logical reasoning. This essay delves into the world of Euclid, exploring his life, his work, and his profound impact on the development of mathematics and beyond. We will journey through the pages of The Elements, unraveling its structure and significance. Join me as we celebrate the legacy of Euclid, a legacy that continues to shape our understanding of the world around us. Euclid's life remains shrouded in mystery, with limited historical records detailing his personal journey. What we do know is that he lived and worked in Alexandria, Egypt during the reign of Ptolemy I Soter, around 305 to 283 BC. Alexandria, a vibrant hub of intellectual and cultural exchange, provided the perfect setting for Euclid's groundbreaking work. The Library of Alexandria, a repository of ancient knowledge, likely played a pivotal role in Euclid's education and scholarly pursuits. Here, amidst scrolls and manuscripts, Euclid would have encountered the works of earlier mathematicians, absorbing their ideas and building upon their foundations. It is believed that Euclid may have received his mathematical training at Plato's Academy in Athens, though this remains speculation. Despite the scarcity of biographical information, Euclid's legacy rests firmly on his intellectual contributions. His writings, particularly The Elements, provide invaluable insights into the mathematical thinking of his time. Through his rigorous approach and elegant proofs, Euclid left an indelible mark on the world of mathematics, shaping its course for centuries to come. Euclid's Elements stands as a monumental achievement in the history of mathematics. This groundbreaking work codified and systematized existing geometric knowledge while also introducing new concepts and proofs. Its impact on mathematics, science, and Western thought is immense. The Elements is organized into 13 books, each building upon the previous ones. It begins with definitions, laying down the basic building blocks of geometry. Euclid introduces 5 postulates, self-evident truths forming the bedrock of Euclidean geometry. From these principles, Euclid derives a series of propositions using rigorous deductive reasoning. Each proposition is accompanied by a detailed proof, demonstrating its validity step by step. At the heart of Euclid's Elements lies a profound appreciation for logical deduction. Euclid built a robust system of geometry on fundamental principles. He distinguished between axioms, postulates, and theorems. Axioms are self-evident truths, like equality. Postulates are specific to geometry, like extending a straight line. Theorems are logically derived statements with rigorous proofs. This deductive approach showcases the elegance of Euclid's system. The Pythagorean theorem, a cornerstone of geometry. Among the many theorems in Euclid's Elements, the Pythagorean theorem stands out as one of the most famous. Named after Pythagoras, it establishes a relationship between the sides of a right-angled triangle. The square of the hypotenuse equals the sum of the squares of the other 2 sides. In mathematical terms, a squared plus b squared equals sine c squared. This theorem has far-reaching applications in mathematics, physics, and engineering. Section 6. Beyond triangles. Exploring shapes and proportions. Euclid's Elements extends far beyond the realm of triangles, encompassing a wide range of geometric concepts and shapes. From the properties of parallel lines to the geometry of circles, Euclid's work lays the foundation for understanding the fundamental building blocks of our spatial world. Euclid delves into the properties of quadrilaterals, exploring the characteristics of squares, rectangles, parallelograms, and other four-sided figures. He investigates the relationships between angles formed by intersecting lines, establishing key theorems that underpin our understanding of angles and their measurements. Circles, with their inherent elegance and symmetry also captivated Euclid's attention. He dedicated an entire book of the elements to exploring the properties of circles, including tangents, chords, arcs, and sectors. Euclid's work on circles laid the foundation for trigonometry, the study of relationships between angles and sides of triangles, which has applications in navigation, surveying, and astronomy. Euclid's influence on number theory. Euclid's work profoundly impacted number theory, the study of integers. His elements include proofs and algorithms on prime numbers and divisibility. Notably, Euclid proved the infinitude of prime numbers. Prime numbers divisible only by 1 and itself are crucial in number theory. Euclid's algorithm for finding the greatest common divisor is still used today. His work shows the interconnectedness of geometry and number theory. Section 8. A legacy of logic and deduction. Beyond specific geometric theorems and number theory concepts, Euclid's most enduring legacy lies in his pioneering approach to mathematical reasoning. The Elements stands as a testament to the power of deductive reasoning, a method of deriving new truths from established principles through logical steps. Euclid's axiomatic method, starting with a small set of self-evident truths like axioms and postulates, and building upon them through logic and deduction, revolutionized mathematics. This rigorous approach ensured the validity of his conclusions and provided a blueprint for future mathematicians to follow. The Elements became a model for mathematical rigor and clarity, influencing the development of mathematics, science, and philosophy for centuries. Euclid's emphasis on logical deduction laid the groundwork for the scientific method, which relies on observation, hypothesis, and logical testing to understand the natural world. Section 9. Euclid's influence on non-Euclidean geometry. Ironically, one of the most significant impacts of Euclid's work was the eventual development of non-Euclidean geometries. For centuries, mathematicians attempted to prove Euclid's fifth postulate, often referred to as the parallel postulate, from the other four postulates. This postulate, stating that given a line and a point not on the line, there is exactly one line through the point parallel to the given line, seemed less self-evident than the others. In the 19th century, mathematicians like János Bolyai, Nikolai Lobachevsky, and Bernhard Riemann challenged the assumption that Euclid's fifth postulate was an absolute truth. They explored alternative geometries where the parallel postulate did not hold, leading to the development of hyperbolic and elliptic geometries. While these non-Euclidean geometries differed from Euclid's system, they built upon the foundation of rigorous logical reasoning that Euclid had established. The exploration of non-Euclidean geometries revolutionized our understanding of space and geometry, paving the way for Einstein's theory of general relativity, which describes gravity as the curvature of space-time. Section 10. Euclid in the modern world. Euclid's legacy extends far beyond the halls of academia, permeating various aspects of our modern world. His work continues to influence fields as diverse as computer graphics, architecture, and robotics. In computer graphics, Euclidean geometry provides the mathematical framework for representing three-dimensional objects on two-dimensional screens. Architects and engineers rely on Euclidean geometry for structural design, ensuring the stability and safety of buildings and bridges. Robotics engineers utilize Euclidean geometry to plan robot movements and manipulate objects in three-dimensional space. Euclid's emphasis on logical reasoning and problem-solving continues to be relevant in our increasingly complex world. His work instills a valuable approach to thinking critically, analyzing information, and drawing logical conclusions. Section 11. Conclusion: the enduring impact of Euclid. Euclid of Alexandria, the father of geometry, left an indelible mark on the history of mathematics and human thought. His masterpiece, The Elements, stands as a testament to the power of deductive reasoning and the elegance of geometric thinking. Euclid's legacy extends far beyond the specific theorems and proofs presented in The Elements. His axiomatic method, his emphasis on logical deduction, and his exploration of fundamental geometric concepts have shaped the way we approach mathematics, science, and problem-solving. From the foundations of geometry to the development of non-Euclidean geometries, Euclid's influence continues to inspire mathematicians, scientists, and thinkers. His work reminds us of the power of human reason to explore the universe and unravel its mysteries. As we navigate the complexities of the modern world, Euclid's legacy of logic, rigor, and the pursuit of knowledge serves as a guiding light, illuminating the path toward understanding and discovery.